right, let's go ahead and dig into some vector multiplication now that we've got addition down pat. And we're going to first define a couple things, and then we're going to run you through some examples of what it would look like, and then we'll do some graphing of some vectors as well. So the first thing that we're going to take a look at is if alpha, that's what this character is right here, is a scalar. I should probably define scalar. We know that vector is a magnitude and direction. A scalar has no direction, right? So it's just a value. So you either have marbles or you don't have marbles, right? There is no such thing as you have 3 marbles southeast, right? That would be if you are actually moving your marbles, and then that would be velocity, which is a vector. Mass is a scalar quantity. There's lots of things that are out there. Energy is a scalar quantity. You either have it or you don't. So if alpha is scalar or a real number, okay, so we're talking about a real number, and v is a vector, the scalar multiple alpha v, v is defined as following. So if, this is 2 words, I'm not sure how we're going to get it to fit in, scalar product. So if it's a scalar product, the product AV is the vector whose magnitude is A times the magnitude of V and whose direction is the same. So essentially it's saying, okay, if I have the number 3 and my vector is V, if I do 3 times V, it's going to equal 3V. So if my initial, vector is this big, then my 3V vector will be 3 times as big, right? So that's what it's saying here. The next bullet talks about if you have an alpha that's less than 0, so you have a negative value. So the product is still the magnitude of alpha times V, but the direction is going to be opposite. Okay, so the fact that that A or that alpha has a negative sign on it means that it's going to change the direction of that vector. And then finally, if alpha is equal to 0, or if v is equal to 0, then alpha times your vector v is going to be equal to 0. Okay, so if either of them do. So just like multiplying real numbers. Okay, so based on what's known about multiplying real numbers, complete the following. I want you to pause this video and see if you can go ahead and answer these numbers. It looks like this should be 1, 2, 3, 4. Okay, go ahead and answer these, and then we will come back and take a look at them together. Okay, welcome back. So we have 0 times v, so of course, obviously that's going to be 0. If I multiply 1 by v, I just get v, same thing, right? If I have negative 1 times v, then I'm going to end up getting a negative value of v, right? It's going to head the opposite direction. With 4, I'm going to go ahead and distribute like I normally would a real number. So I'll end up with alpha v plus beta v. And then here I have alpha multiplied by 2 vectors that are added together. So that would be the same as alpha v plus alpha w. And then I have alpha beta v. It doesn't matter when you multiply what order you have. So I could actually use the associative property and say, well, alpha b times v works as well. Okay. All right, let's look at graphing the 2 vectors. So there are 3 items here. It's going to be a little bit difficult to do this exactly, but we will do what we can to make it work. Okay, so I'm going to add a piece of graph paper. So squared paper, let's do that. Okay, so I have graph paper, and I'm going to go ahead and grab a picture of this. So I'm going to grab a picture of this. and then edit this so that we have just this portion on our sheet. That's what we want. And then we're going to turn the page and we're going to add this picture at the top. So there's our picture. Here we go. All right. So the first one I have is 2v minus w. Okay, so my v, if you take a look at it, is 3 over 1 or 2 up. So 3 over 2 up. And if we're going to do 2 of those, then I'm going to go 3 over 2 up, 3 over 2 up. So that's going to look like this. Okay, so this is going to be 2v, and then I'm going to subtract a w. The w goes down 2 and over 2. But this is negative, right? You have minus. So I'm going to be heading the other direction. So that would be up 2 and over 2. So just like that. So here's my w and here's my 2v. And so my resultant vector here would be this right here. So this would be 2v minus w. Okay, that's not so bad. The next one, b, we're going to look at v minus 2w. So v, we have that again, just 1v. So that's over 3 up 2. So that's v. And then minus 2w. Well, we know that our w goes 2 up, 2 over. Well, 2 over, 2 down is our normal w, but I have negative 2w. So that's going to go up this way twice. So that's going to be this and then this value. Okay, so we should have a resultant vector that looks like this. So this is actually going to be v minus 2w, where this is 2w. All right. And then the last one is v plus 2w minus u. So the u is going to have to go the opposite direction when we get that. So let's do v. So that's 3 over 2 up. So we've got that. And then plus 2w. So we're going to go 2 over, 2 down twice. That would be this. So this is v, this is 2w. And then our u would go over 1, up 3, but because it's minus, it's going to go down 3 over 1. So that's going to look like this right here. So this is u, or negative u, I should say. So then this is what our resulting vector would look like, right? So this is v plus 2w minus u. All right, so that's how we do our vectors. It's that tip to tail method. And again, by just multiplying by a value, we're just going to extend it another one. All right, let's go back to our notes. Let's go ahead and look at some of these properties and get them defined here. The symbol double line with a V inside of it, I did that on our previous exercise. And that just represents the magnitude. So if we're talking about just the value or the number of a vector without any of the direction or anything, that's going to be your V. So we have the properties of the double bar V theorem. If V is a vector and if alpha is a scalar, V is greater than 0. It is because this is just the magnitude, right? You can't have a negative value on a magnitude because that negative value actually shows the direction. So this is magnitude only, right? If you have V would be equal to 0 if and only if v equals 0. So the only time you get 0 as your magnitude is if your initial vector has a value of 0. And then you have the double bar of negative v is going to equal just regular v, right? Because that's just your magnitude. So it doesn't matter if it's negative on the inside, you're still going to get a positive number. It's kind of like absolute value, but not really, because the concept is absolute value, but then you're not having a direction. So maybe that's why they have the two lines. And then the last one is a or alpha times v is going to equal the absolute value of a, because it's not a vector, we can't do the double bars, right? Times our value of v, which can be inside those double bars. Okay, last one, definition. A vector u for which u is inside the double bars that equals 1 is called a unit vector. Okay, so we're going to talk about those unit vectors next, and it gets kind of crazy.